All right. What is up, everybody? Tom McGurl here with another episode or stream from our Learn Rust live series. Took a little break last week to spend some time with the family for the holidays, but we are back now, and we're going to be picking up where we left off in the Rust book, starting from chapter 12. We did chapter 11 2 weeks ago, where we learned about automated testing. We wrote some unit tests, some integration tests. And now this chapter is going to be all about taking what we've learned from, pretty much all of the chapters and applying it to build an actual command line tool. It's going to be pretty interesting. I'm not sure how much of it they're going to walk us through, how much we're going to be doing ourselves. We'll kind of figure that out as we go along. But I'm excited for it. And yeah, it should be fun. As usual, quick just updates on things going on. So again, the stream is from 9 to 11 p.m. every Tuesday. We took a break last week, but we're back, and we're going to be continuing with that schedule. If you've missed any of the previous episodes, do not worry. We got them all here on YouTube. You can see my YouTube name above, Tom McGurl. All the videos are posted here. We have the start of when we started the book, chapters 1 through 10. We got some one-off videos on. Here's one on Rust development with Docker. So if you want to see how to get a Rust development environment set up with Docker composed pretty easily, that's awesome. We also took a little break from the book to do the Rustlings exercises. We went through all the exercises with the exception of one, which was on threads, because we didn't know how to do that yet, which was a lot of fun. It was a way for us to flex the muscles from what we learned while going through the book. And it was just a really fun time. So definitely check those out. Those are up here as well as the one from 2 weeks ago on chapter 11, which was all about automated testing. So, even if you're not following along, but you're interested on any of the topics for each of the chapters are listed there. So just jump around. All here on YouTube. You can watch it at 1.5 speed. Slow it down if you want to hear it in slow motion. Or speed it up if you want to hear it like this. Your call. However you want to watch it, it's all there on YouTube. And if you want to get updates on when new videos are posted, subscribe, and that like button always helps, right? All the streamers got to say, subscribe, hit the like button. But yeah, for real though, we mean it. Do it. If you're catching it live on Twitch, feel free to ask any questions in the chat as we go. It's fun. We always try to make it a little interactive, so that's awesome. If you want updates on when I go live, as usual, it's on my Twitter. My Twitter URL is above as well. I post some tweets there, as well as whenever we go live. You can see here some going live posts. The code that we write here today will be posted to my GitHub, specifically this repo, the Learn Rust Live repo. So all the code will be added there. It gets pushed up right at the end of the stream. So if you want to pull that down, look at some of the stuff we already did. If you want to follow along, if you want to have your own code, do that as well. You can use this as reference. But that's just there just in case you want to follow along or see where we are going with things. You can also find some code bases from some of our other video series. Here we have one on serverless API, and that's this video here, which is building a serverless API with AWS Lambda, DynamoDB, TypeScript, Node.js, and using S3 for file storage. So that was a pretty fun one. Another one of our 2-hour streams, but really fun and pretty cool. Other than that, we have our React Native app that we also built and just some other repos. And I'll be trying to post more here as well. And I'll also be trying to put more one-off content on YouTube starting in the new year. It's going to be one of my resolutions. I usually don't do these kinds of things, the resolutions, because, let's be real, I never keep them. No, I'm going to try to just do some more one-off content, just some smaller videos that, you all can get in and feel things out and learn. We'll do some more stuff. One of the things I'm thinking about doing is trying out Next.js. I've been hearing great things. I've used Gatsby in the past, but I've been hearing awesome things about Next.js, so probably going to do something on that. And then, of course, we're doing Rust, so I might do some more Rust stuff. I'd love to get some smaller programs written, maybe explore some crates, things like that. So, yeah, we'll check that out. But today, we're going to go in. We're getting in the books. We're getting our glasses on. I'm in the crypt, right? I'm like Gandalf, going through, looking for about the ring in the library, right? We're going through the book. Why are we going through the book? Because I've mentioned this on past streams. I usually like to jump right in, right? Jump right in. Like the Zach Brown Band song. I like to jump right in and start coding a language. But with Rust, everybody I've spoken with and from experience has said, this is the type of language where you want to go through the book because you want to get an understanding of what you're doing. And we saw that. When we tried to do some of the Rustling exercises without the background info, it was a little tough. And I didn't want to just go in and do stuff and not understand what I was doing. And so that's why we do the book, is going to help us kind of get that understanding. It's been fun. The book has exercises. It's been a lot of fun. I'm learning a lot. we're about to build a command line tool. So let's jump into it. Before we do that, though, as always, got to give a shout out to the authors. Of course, without the authors who have taken their time, their free time, to write this book for the community so that they can build the community of rustaceans, the little crabs, right? We want to build the community of little rustaceans. And we couldn't do that without the authors. So huge shout out to Steve Klobnik and Carol Nichols and anyone from the Rust community who has contributed to this. It's been fantastic. Again, we couldn't be doing this without their contributions. And it's really helped us, right? We're learning Rust. I mean, it's been a lot of fun. And so thank you to them for all their contributions. And definitely follow them on Twitter or social media. See what they're up to. I've watched some awesome talks from Carol Nichols on Rust on YouTube. So check those out as well. All right, so today, all about chapter 12. So what is chapter 12? We're going to be building a command line tool. I read ahead a little bit, and I know what we're going to be building. We're going to be building a grep clone. You can also see it because it's highlighted a bunch of times in the text. What is grep? It's a tool that allows you to search your file system, right, for strings. But, I don't want to tell you everything. Let's just read through it together, and we'll see where it goes. I don't know how much, as I mentioned before, I don't know how much hand-holding there's going to be. I don't know if it's going to just have us copy the code or make us come up with stuff on our own. I hope it's a little hands-off where we can try to figure stuff out ourselves. But we'll see. Either way, we're going to have fun. We're going to use what we've learned. We're going to flex those muscles that we've learned, kind of like we did with Rustlings. And let's just have fun with it. All right. Let's go. So this chapter is a recap of many skills you've learned so far and an exploration of a few more standard library features. Let's go. We'll build a command line tool that interacts with file and command line input-output to practice some of our Rust concepts you now have under your belt. You know what's under my belt? About 10 extra pounds from the holidays, you know what I'm saying? Yeah, for real though. Rust speed, safety, single binary output, and cross-platform support make it an ideal language for creating command line tools. So for our project, we'll make our own version of the classic command line tool, grep. Oh, it stands for globally search. Wait a second. This is what it stands for. I never knew this. Globally search a regular expression and print. Globally search regular expression and print. You all probably knew that. You're like, Tom, you didn't know that? Dude, this guy doesn't even know what grep means. No, I didn't know. I know now. All right? And you probably know now too. In the simplest use case, grep searches a specified file for a specified string. To do so, grep takes as its arguments a file name and a string. So let's imagine we had a file called Tom's Books on His Bookshelf, right? And you searched Halo, or let's say you searched Silmarillion, and you want to search for a word in there, you could do it. That's how it works, right? So you give it a file, a string, searches for the string within the file. Pretty straightforward. To do so, grep takes its arguments, the file name and a string, then it reads the file, finds lines in that file that contain the string argument, and prints those lines to your command line. So it prints out the line where it finds that string. Along the way, we'll show how to make our command line tool use features of the terminal that many command line tools use. We'll read the value of an environment variable to allow a user to configure the behavior of our tool. Excuse me. We'll also print error messages to the standard error console stream, standard error, instead of standard output. So for example, the user can redirect successful output to a file while seeing error messages on screen. You may have done this before. If you've ever worked with something where you're trying to log and you want to output to a file, it doesn't spit the errors to that file, right? It spits the errors to the page or to your command line while you're viewing it, and it only puts the correct output to the file, the standard out. So pretty cool. All right. One Rust community member, Andrew Gallant, I hope I pronounced that right, or Gallant, has already created a fully featured, very fast version of grep called ripgrep. We'll have to check that out. By comparison, our version of grep will be fairly simple, but this chapter will give you some of the background knowledge you need to understand a real-world project such as ripgrep. Our grep project will combine a number of concepts we've learned. So organizing code, we learned that in chapter 7. We haven't done much of that. We did a little bit in the integration test, but beyond that chapter, we haven't really structured a project, so that'll be interesting. Vectors and strings, we've definitely done that. Handling errors, right? We've done question mark, we've done panic, we've done option, result type, so definitely done some of that. Using traits and lifetimes where appropriate. We've talked about traits, right? We use the copy trait, we have the debug trait, the display trait, so we've done some of that. And writing tests, which should be pretty fresh, right? We only did it 2 weeks ago. And of course, what we're going to do, all this is in the same repo. And we've been following along with the book in this repo that I have here. Again, it's on GitHub, so feel free to pull it down here. And this is going to have all of our past work here, right? So you'll see we have our chapter on automated tests, generics, traits, and lifetimes, which actually I just noticed our chapter on automated tests might not actually be pushed up. So let me just go ahead and push that now. So you have that. Whoa. All right, now it's there. So now everything's there. So what we can do is we can reference these chapters as we need to. So like if we forget how to write tests or something like that, we can pull up our tests, our lib, and we have a bunch of examples on tests. So all we can use, we're going to use everything we've written. We're going to reference it all the time throughout this. So that should be pretty cool. All right, we'll also briefly introduce closures, iterators, and trait objects, which chapters 13 and 17 will cover in detail. So we're going to have some new topics that we haven't talked about, closures, iterators, and trait objects, but we'll get into them in future chapters. So, all right, I'm down for it. I'm down for the quick intro. Let's jump in. Accepting command line arguments. So we talked about it. We're going to have to take a file name and a string that we want to search. So we're going to have to learn how to take arguments. In the past, we've taken arguments via standard in by prompting the user, but this is actually going to take them as arguments to our cargo run, which should be pretty cool. Okay, so let's create a new project with, as always, cargo new. We'll call our project mini grep to distinguish it from the grep tool that you might already have on your system. All right, so let's pop this bad boy over here. Let's go over here. And what I'm going to do is I'm going to create a new project. Let me move out of your way for a second. So first I'm going to create, in my projects folder, I'm going to create a new folder for chapter 12. We'll call it grep. What are we calling it? Mini grep? We'll call it mini grep. I called it min grep. Let's just remove that. Rename that. So make dir chapter 12 mini grep. And then we'll go into there. And then we'll create another folder in here called mini grep by just doing cargo new mini grep. All right, awesome. So now if I open up my file system here, we have chapter 11, here's chapter 12, source main. So there's our mini grep hello world. And of course, if we ran cargo run, we'll see, oh, let me go into mini grep, cargo run. You'll see that it's just printing out hello world as is expected because that's all we have currently. All right, so we created a new one. We called it mini grep to distinguish it from the grep tool. And the first task is to make mini grep accept two command line arguments, the file name and the string to search for. That is, we want to be able to run our program with cargo run, a string to search for, and a path to the file to search for that string in. Here's an example. Cargo run, the string we want to search for, and the file name. So our first argument, what we want to search for, second argument, file name. Right now, the program generated by cargo new cannot process arguments we give it. Some existing libraries on crates.io can help with writing a program that accepts a command line argument. But because you're learning the concept, let's implement this capability ourselves. Oh, so we could pull a crate, but this book is like, you've come so far. Your wisdom is great. Why not implement it yourself? So we're going to do it. We're going to be like, all right, book, we'll do it. All right, I'm ready. I don't need a crate for this. We're going to do it ourselves. It's pretty cool. I think it's a cool way to learn something, right? Let's do it. Reading the argument values. To enable minigrep to read the values of the command line arguments we pass to it, we'll need a function provided in Rust standard library, which is standard environment args. This function returns an iterator of the command line arguments that were given to minigrep. An iterator, right? We learned about iterators, so we're good. We'll cover iterators fully, though, in chapter 13. We touched upon them in Rustling, so if you were watching in the Rustling stream, we used them a bit. But we used collect on them, right? Remember, we collected into an array, and you can see it here. It collects it into whatever the type is. We'll see. For now, you only need to know two details about iterators. Iterators produce a series of values, and we can call the collect method on an iterator to turn it into a collection, such as a vector containing all the elements the iterator produces. use the code in listing 12.1 to allow your mini grep program to read any command line argument passed to it and then collect the values into a vector. Okay, so we're going to write this out. And I'm not just going to copy it. I kind of want to write it because I want that experience. Just fast forward if you're uninterested. All right, so let args. And this is a cool thing. And maybe I could have sworn we read about this in the book, but maybe not. Maybe it was in Rustlings. But whatever we specify the type as here, collect will collect that iterator into this type. So it's pretty interesting. So we were able to use collect without specifying a type. And then what you can do is you can specify it on the call to collect. But by specifying it here, Rust will infer you intend to collect the iterator into this type. So first, we need to import that use statement, right? Because we're going to use standard env. And you can see we're not specifically using args. We could pull in args and just call it args, but we're actually going to just pull in up to env, and we're just going to call it like this. And that's because we're going to use a variable called args. If we imported args completely, we wouldn't be able to do this here, right? Okay. So let's do it. Env args dot collect, and now we have our args, and then we're going to print them to the screen. Apparently we're using the print macro, and this is, I believe, the debug. Hold on, I messed something up here. All right, there we go. Oh, it's just the syntax highlighting args. All right. Also, if you're wondering about the theme, we did switch themes recently. We're using one of our stream participants here that pops in the chat, Greyjack. He created this theme. It has Rust-specific syntax highlighting, so we're going to give it a shot. I've been enjoying it. I'll put a link to it in the show notes if I haven't already. All right. So it says here, we bring in standard env into the scope and use the use statement so we can use the args function. Notice that the standard env args function is nested in 2 levels of modules. As we discussed in chapter 7, in cases where the desired function is nested in more than one module, it's conventional to bring in the parent module into scope rather than the function itself. By doing so, we can easily use other functions from standard env, right? That's why we didn't pull in the full thing. It's also less ambiguous than use standard env args and then calling the function with just args, because args might easily be mistaken for a function that's defined in the current module. So by seeing it with the colon, we know that it's most likely from another module. So that's kind of a cool little pattern to practice. The args function and invalid Unicode. Note that the args function will panic if any argument contains invalid Unicode. If your program needs to accept arguments containing invalid Unicode, use standard env args os instead. That function returns an iterator that produces os string values instead of string values. We've chosen to just use the standard args here for simplicity because OS string values differ per platform and are more complex to work with than string values. All right, makes sense. So I'm happy with that. We'll just continue with the regular string args. I'm sure these are operating system args. I'm not sure what those will be used for, so let's see. On the first line of our main, we call env args, and we immediately use collect to turn the iterator into a vector containing all the values produced by the iterator. We can use the collect function to create many kinds of collections, so we explicitly annotate the type of args to specify that we want a vector strings. That's basically what I was mentioning. We could have also put this here, and it would be the same. We could have put it like this, right? And it would have handled that. Something like that. I forget the exact annotation, but that could have worked. All right, so let me see what's going on here. All right, so we're going to leave it as that, and let's save that. Okay, so then here, this is another thing. So finally, we print the vector using the debug formatter. Remember this? Let's try running the code first with no arguments and then with 2 arguments. All right, let's try running it. So I'm going to pop myself out of your way over here in the bottom left. Look at that. Watch that. Pretty cool. Magic, right? Stream magic. All right, so here we're going to do cargo run with no arguments. And nothing got printed out. Nothing happened. Void, right? We didn't do anything in the function. Let's try passing it. Arguments. So they're calling it with needle haystack. That's clever. That's cool. we're not doing that. We're going to call it with cargo run what up Twitch. What up Twitch. All right. And there you go. You can see the arguments. So the first one is, the first argument is the command that we actually ran. That's pretty cool. So the first argument is actually the program, and we see that here. Second argument is what up, and the third is Twitch. So we're looking at the index 1 and index 2 is what we're interested in. We can skip over that first one because that's just the name of the program. Of course the book's going to say exactly what I said. Come on. Notice that the first value of the vector is target debug mini grep, which is the name of our binary. This matches the behavior of the arguments list in C, letting programs use the name by which they were invoked in their execution. That's pretty cool, right? It's often convenient to have access to the program name in case you want to print it in messages or change the behavior of the program based on what command line alias was used to invoke the program. So maybe you want to tell the indicator, which program is spitting out this input. There's a few reasons you want to do that, right? Maybe you're running multiple things in parallel. Maybe you just want to send a message to the user's terminal or logs that have the program name that are generating the logs, right? So a few reasons why you would do that. But for the purpose of this chapter, we'll ignore it and save only the 2 arguments we need, which are at index 1 of the array, right here, and index 2. Sounds good? All right, let's move on. Saving the argument values in variables. Printing the value of the vector of arguments illustrated that the program is able to access the values. Wait, hold on. Whoa, that was a lot. Printing the value of the vector of arguments illustrated that the program is able to access the values specified as command line arguments. So it shows that we have access to them as command line arguments, right? Now we need to save the values of the 2 arguments that we actually care about so we can use the values throughout the rest of our program. And we're doing that here in this next listing. So how are we doing it? It looks like we're going to say query, which is the search string, equals, and we're grabbing a reference to args 1. So that's index 1. Remember we mentioned index 1 here. You can see that, right? Yep, index 1 is this. Index 2 is Twitch. So we're going to grab the thing at index 1. All right. And we're going to call that query. And the file name will be the thing at index 2. And just right off the top of my head, and I'm sure you're thinking the same thing, there's going to be we're going to have to do some sort of validation or checks, right? Because it's possible that you provide an invalid file name. Maybe you accidentally provide the file name first. And so I'm sure our program is going to, because Rust is very safe, right? It's going to allow us to do things that can help us check that the correct things were input and make sure that the file exists before we try to search for the string, make sure that it's a valid file, and so forth. And so that's why we're using Rust for this type of stuff. It has that safety built in. It's going to allow us to do that. It's going to allow us to return errors, and it's going to allow us to access things in a safe manner. So I'm pretty excited. All right, next we're going to print the names of those args. All right, so let's do that. Print ln. And so the first thing is searching for, and we're going to put the first thing we're searching for, which is query. And then here we're going to do in file and file name. All right. As we saw, we printed the vector. The program's name takes up the first value in the vector. So we're getting the one at index 1 and index 2. So that's pretty clear. All right, we temporarily print those to prove that the code is working. So let's try it. Let's prove that it's working. So let me move out of the way again. And let's run that. Oops. That was weird. All right, so let's run that again and see what's going on. So I'm going to go cargo run, and I'm just going to say, let's give it an example. Dependencies cargo.toml. Unexpected token. Why? Because we forgot a semicolon here. Let's clear that out and run it again. All right, so here we can see searching for dependencies in file cargo.toml. Awesome, we're good. We're getting the right arguments. Things are working. Let's move on. All right, great. The program is working. The values of the arguments we need are being saved into the right variables. Later, we'll add some error handling to deal with certain potential erroneous situations, which we talked about, right? For now, we'll ignore that situation and work on adding file reading capabilities instead. Let's do it. Reading a file. Now we'll add functionality to read the file that is specified in the file name command line argument. First, we'll need a sample file to test it with. All right. The best kind of file to use to make sure Mini-Grep is working with is one with a small amount of text over multiple lines with some repeated words. Listing 12.3 has an Emily Dickinson poem that will work well. Create a file called poem.txt at the root level of your program and enter the poem, I'm nobody, who are you? All right. I'm sure we could write our own poem. We'll use this one for now. We'll use this one. I like it. So we're going to call it poem.txt. All right, so let's do that. So let's go here. Chapter 2. Where are we adding it to? Where are we putting it? The root level of your project. Okay, so here's the root level of our project. We're calling it poem.txt, and it's going to contain this text. I can just copy right there. Look at that. Let's read the poem. Fast forward if you're not interested. I'm nobody. Who are you? Are you nobody too? Then there's a pair of us. Don't tell. They'd banish us, you know. Wow, this is deep. How dreary to be somebody. How public, like a frog, to tell your name the livelong day. To an admiring bog. Yo, come on. I could write something better than that. Not knocking it. I'm sure it was good in the day, but frog, bog, come on. Come on. Emily. Come on, Emily. Could do better than that. James Harris is in the chat. What up, James? I hope you enjoyed that amazing reading of this fantastic poem. Okay, let's go. So, with the text in place, edit main rs and add the code to read the file. All right, let's do it. I'm excited. So we're going to read the file. First, we're going to want to pull in standard file system. All right. Now, we're going to keep this code, right? We're going to keep this here, and that's why they have the snip. We're just going to add some extra stuff. So here, we're going to get the contents. Equals, so file system read to string is what we're going to use, read to string. Okay, and we're going to give it the file name. And again, this could error, right? The file name could be bad. And we're going to handle those in just a bit. So we're going to do .expect. That's going to handle the error. And you can see here, we have a printout. So it says expect returns the contained OK value consuming the cell value. Panics if the value is an error with a panic message including the past message and the contents of the error. And we can actually scroll through and see some usage. So here we can just say expect, testing, expect. So what we're going to do is we're going to expect, we're going to give it a message that's pretty useful. Something went wrong reading that lame poem. Just kidding. That reading the file. Perfect. I like to end my sentences with periods. And so now we have our contents, and let's just print out the contents so we can see if it actually worked, right? So let's do print ln with text. This is a new line, so it's going to put it on the new line, just formatting, and then we'll send it our contents. So let's try that out. And we're going to try it two ways. We're going to try it with a valid file, and then we're going to try it with an invalid file. But let's first read the book a little bit, and it'll tell us what we're doing. But it's pretty clear, right? So first we add a use statement to pull in the file system. We add a statement fs read to string, which takes the file name, opens that file, and returns a result string of the file contents. So we get a result from this. So we could use a match, right? We could do the OK and the error, or we could use the question mark. But we're using expect because it's very easy. After that statement, we added, again, a temporary print to print the contents of the file. So let's run it. We're going to run it with the correct poem, and then we'll run it with invalid input and see what happens. All right, out of your way. There you go. So let's clear this out, and let's run cargo run. And what are we going to search for? Here it has us searching for the in poem.txt. Okay, so there we go. We can see it printed out, that fantastic poem. It's not a good poem. Maybe I don't know poetry. I don't know. Kind of boring. All right, so it prints out that poem, and it doesn't search. Obviously, we didn't code that yet. I want to try with an invalid text file and see if we get our error. So I'm gonna do poem.text, which isn't a thing. And there we go. Thread main panicked at something went wrong reading the file. Awesome, we're covered. That's great. All right. The code read and then printed the contents of the file. But the code has a few flaws. The main function has multiple responsibilities. Generally, functions are clear and easier to maintain if each function is responsible for only one idea. For sure. If you're coming from any other programming language, maybe JavaScript, maybe Java, maybe Python, maybe Elixir, maybe you're doing some Crystal. Not that kind. I'm talking about the programming language. Maybe you're doing C, whatever you're doing. I'm sure you've come across a point where you want to break your code into different functions, right? Single responsibility, something like that. So hopefully we're going to do that now. The other problem is that we're not handling errors as well as we could. The program is still small, so these flaws aren't a big problem, but as the program goes, it'll be harder to fix them cleanly. It's good practice to begin refactoring early on when developing a program because it's much easier to refactor smaller amounts of code than large amounts of code. We'll do that next. All right, let's go. Let's jump right in. Jump right in. All right, refactoring to improve modularity and error handling. Let's do it. To improve our program, we'll fix 4 problems that have to do with the program's structure and how it's handling potential errors. First, our main function now performs 2 tasks. It parses arguments and reads files. For such a small function, this isn't a major problem. However, if we continue to grow our program inside main, the number of separate tasks the main function handles will increase. You get that? You picking up what that's putting down? It's basically saying, yeah, we have a simple thing right now, but it's still doing 2 things, right? It's reading arguments, it's reading files. Not a problem for such a small program, but as this program begins to build, it makes it so that the main becomes almost like a single point of failure. All of your stuff is happening there, whereas we could break it up. It also makes it much more difficult to test. Whereas if we broke it up, we could test each individual responsibility separately and ensure that our parts work, right? Unit tests. Okay. It becomes harder to test, harder to change one of its parts. It's best to separate functionality so each function is responsible for a single task. This issue also ties into the second problem. Although query name and file are configuration variables to our program, variables like contents are used to perform the program's logic. So what does that mean? Query and file name are arguments, right? They're given to us. We create them, but contents are actually used within the file to perform operations. So it's a little bit different, right? The longer main becomes, the more variables we'll need to bring into scope. The more variables we have in scope, the harder it will be to keep track of the purpose of each. It's best to group the configuration variables into one structure to make their purpose clear. Okay, so we're running into some concepts that are definitely common among programming languages. Basically, what we're talking about here is make things smaller pieces and use them together, right? Bring pieces together. So you have small functions that do separate things and compose them. It's a very common practice, right? We talk about it on the programming level. We talk about it on the systems design level, right? If you've heard of microservices, single responsibility, right? And we want to make things easy to understand. Now, this is a quick aside, but it's very important. We spend more time reading code than writing code. So making it really easy to read for both us and future us and others is extremely important. It makes things a lot easier to understand, a lot easier to build, and the time to make a change in a code base that you can read is a lot less if it's readable, right? You don't want to spend a lot of time saying, what the hell is this doing? So pretty cool stuff. Good tips. Okay, there's a third problem. Of course, there's always problems, right? We got tons of problems here. Third problem is that we used expect to print an error message when reading the file. Fails. But the error message just prints something went wrong reading the file. It gives you no details. It's pretty boring. It's like a bad witness, right? They don't tell you any of the details. They're just like, I saw the thing come out of the woods. It got to me, right? Reading a file can fail in a number of ways. For example, the file could be missing, or we might not have permissions to open it, right? There's a few reasons this could fail. It might be a bad file name, like we provided, poem.text. It might be that it actually finds a file, but the file has permissions and it couldn't pull it open. It might be that it's an archived file and it couldn't open it without unzipping it. A few different things, right? So the fourth reason We use expect repeatedly to handle different errors. And if the user runs our program without specifying enough arguments, they'll get an index out of bounds error from Rust that doesn't clearly explain the problem. It would be best if all the error handling code were in one place, so future maintainers had only one place to consult in the code if the error handling logic needed to change. Having all error handling code in one place will also ensure that we're printing messages that will be meaningful to our end users, right? Clam Watson with the lull. Love that emoji. Let's address these 4 problems by refactoring our project. All right, let's get into it. Separation of concerns for binary projects. What is a binary project, you might ask? A binary project is exactly what we're using here. We ran cargo new. We didn't say cargo new lib, right? If you create a library, sometimes you have a library, we're using a binary project, so we have our main, right? So that's what we're doing. We're dealing with a main.rs. All right, the organizational problem of allocating responsibility for multiple tasks to the main function is common to many binary projects. As a result, the Rust community has developed a process to use as a guideline for splitting the separate concerns of a binary program when main starts getting large. The process has the following steps. It's a checklist, right? So we're going to look at this. We're going to do each of these steps. 1. Split your program into a main RS and a lib RS and move your program's logic to lib RS. Whoa. Let that sit for a minute. Right? As long as your command line parsing logic is small, it can remain in main RS. When the command line parsing logic starts getting complicated, extract it from main RS and move it to lib RS. So pretty cool. So again, 1, split your program into main RS and lib RS and move your program's logic to lib RS. Okay. 2, as long as your command line parsing logic is small, it can remain in main RS. So if it's small, keep it in main RS. If it's not, move it out. When the command line parsing logic starts getting complicated, extract it from main RS and move it to lib RS. All right. So we're going to create this lib RS. That sounds awesome. The responsibilities that remain in the main function after this process should be limited to the following. 1, calling the command line parsing logic with the argument values. 2, setting up any configuration. 3, calling a run function in librs, so calling out to a librs. And 4, handling the error if run returns an error. So we're gonna kind of like migrate the logic of the program to a librs and let the main just handle the general running of the program. We're going to call out to this run function in the librs. Pretty cool. We have not done this before. It's pretty cool. Pretty excited about it. Let's give it a shot. All right. This pattern is about separating concerns. Main RS handles running the program. librs handles all the logic of the task at hand. Because you can't test the main function directly, this structure lets you test all of your program's logic by moving it into functions in librs. The only code that remains in main RS will be small enough to verify its correctness by reading it. Let's rework our program by following this process. Let's do it. Extracting the argument parser. All right, so we're going to create that librs. We'll extract the functionality by parsing arguments into a function that main will call to prepare for moving the command line parsing logic to source librs. All right, so we're going to prepare by moving it out to a separate function for now, then we'll move it to a different file. Awesome. All right, so listing 12.5 shows the new state of main that calls a new function called Parse Config, which we'll define in source main for the moment. All right, so we're going to put it here temporarily. So let's go ahead and do that. So we got a function, Parse Config, args, ampersand, string. So we're getting a reference to an array of strings, and we're going to return a tuple of string slices. Awesome. All right. So we're going to let query equal args. So this is the type that args is right now, right? If I hover over this, maybe it'll show me. Yeah. So it's a growable string is what's inside, right? So we're going to do args. We're going to just basically copy this code here. All right. and we're going to return query and file name as a tuple. So pretty straightforward. We're going to pass args to parse config. It's going to pull out the query and the file name and just return them as a tuple. Now we're going to use that tuple here. So instead of declaring file name and query like this, we're just going to say let query, this is destructuring, file name equal parse config, and of course we're going to pass it our args, and we're going to pass it a reference to args because that's what we expect on the parse config function. All right, pretty cool. Let's run it. I just want to make sure things are still working the same way they should. So let's do cargo run the and poem.txt. And yep, we still have the and poem, searching for the in the file poem. So we're still good. Sweet. All right, let's go. We're still collecting the command line arguments into a vector, but instead of assigning the argument value at index 1 to the variable query and the argument of value index 2 to file name within the main function, we pass the whole vector to the parse config function. The parse config function then pulls out each of those variables and passes it back as a tuple to our main function. We still create the query and file names variables in main, but main no longer has the responsibility of determining how to get those arguments, right? So that's pretty cool. So we separated out that responsibility to the parse config function. This rework may seem like overkill for our small program, but we're refactoring in small incremental steps. After making this change, run the program again to verify that the argument parsing still works. All right, so we did that. It's good to check your progress often to help identify the cause of problems when they occur. So that's key, right? We're going to keep running it, making sure things still work. I'm feeling it. I think it's pretty sweet. It's pretty sweet. Let's go. Grouping configuration values. We can take another small step to improve the parse config function further. At the moment, we're returning a tuple, but then we immediately break the tuple into individual parts again. This is a sign that perhaps we don't have the right abstraction yet. Interesting. Another indicator that shows there's room for improvement is the config part of parse config, which implies that the two values we return are related and are both part of one configuration value, right? We're not currently conveying this meaning in the structure of the data other than by grouping the two values into a tuple. So what it's basically saying here is we've called it parse config, but there's no indication that the things returned are the config. They're just a tuple. We could probably better group those into something that indicates that these are configuration arguments or variables, right? We could put the two values into one struct and give each of the struct fields a meaningful name. Doing so will make it easier for future maintainers of this code to understand how the different values relate to each other and what their purpose is. So we're giving it more clarity, right? So it's pretty straightforward. That's awesome. Note, using primitive values when a complex type would be more appropriate is an anti-pattern known as primitive obsession. What? Using primitive values when a complex type would be more appropriate is known as primitive. Yo, they're calling us obsessed with primitives? Oh, whew. Primitive obsession. Sounds like a X-Files episode. Anyway, moving on. 12.6 shows the improvements to parse config function. All right. So what are we doing? We're making it more specific. We're going to create a struct called config. So we'll create this config. Oh yeah. So we got config, and we're going to put query, and query is going to be a string, and file name is also going to be a string. All right, and now instead of returning a tuple, we're going to return a config struct so that we know what we're dealing with, right? We're dealing with config. And so here what we'll do is we'll just change this to config, and of course these become these. All right. One thing worth noting is it's complaining, and you'll see why in a second. So it's saying that expected a string, but found a standard string, a reference to a string, right? So that's why they're using clone here. And they're going to go into it. So let's just write that, and then we'll read why they're doing it. All right, easy enough. And we've used clone before. All right, so now it's saying, oh, you know what? It's because we don't want to grab these references, right? There we go. And now we have to change this here, right? Because we're going to change this to config. And now here, instead of just doing query, we're going to do config.query. And yes, it's a little more verbose, but it actually tells us what these things mean, right? We know that these things now come from the config, which is actually pretty nice. All right, let's run it. Remember it said to run it and make sure our stuff still works, so let's do that. All right. There we go. So we still got the and poem.txt. Obviously our program fails because there's nothing going on. I gave it the wrong file name. Let's give it the right file name. And there we go. We got the text from our poem, right? We got poem.txt, so we're doing good. We're killing it. Let's go. On the next one. All right. Main.large. That's what we're going with. We've added the struct name config, defined to have two fields, right? We have query and file name. The signature of parse config now indicates that it returns a config value in the body of parse config, where we used to return a string slice. So we used to have string slices that reference string values in args. We now define config to contain owned string values. That's key. Let's just go over that one more time, right? The signature of parse config now indicates it returns a config value. In the body of parse config, when we used to return string slices that reference string values in args, right? It used to just reference the ones from args. We now define config to own the string values, and that's why we're using clone. The args variable in the main is the owner of the argument values and is only letting the parse config function borrow them, which means we'd violate Rust borrowing rules if config tried to take ownership of the value in args. We could manage the string data in a number of different ways, but the easiest, though interesting, somewhat inefficient route is to call clone method on the values. So we're taking the values and we're cloning them so that config can own them. This will make a full copy of the data for the config instance to own, which takes more time and memory than storing a reference to the string data. However, cloning the data also makes our code very straightforward because we don't have to manage the lifetimes of the references. In these circumstances, giving up a little performance to gain simplicity is a worthwhile trade-off. Awesome. Let's read a little bit blurb about the trade-offs of using clone. There's a tendency among many rustations, that's us. It's us now, right? Rustations. There's a tendency among many rustations to avoid using clone to fix ownership problems because of its runtime cost. In Chapter 13, you'll learn how to use more efficient methods in this type of situation, but for now, it's okay to copy a few strings to continue making progress because you only make these copies once and your file name and query string are very small. It's better to have a working program that's a bit inefficient to try to hyper optimize code on your first pass, right? So we're not doing kind of premature optimizations. We want code that's a little more readable, maybe sacrifice a little bit of that. As you become more efficient with Rust, it'll be easier to start with the most efficient solution, but for now, it's perfectly acceptable to call clone. So I like that. They're giving us some tips. They're telling us why we're doing it, right? It's pretty cool. All right. So we've updated main, so it places the instance of config returned by parse config into a variable named config, right? And we updated the code that previously used separate query and file name variables to now use the config struct instead. Now our code more clearly conveys that query and file name are related and that their purpose is to configure how the program will work. Any code that uses these values knows to find them in the config instance in the fields named for their purpose. So it makes sense, right? You're reading like, no, you know, this is config, right? All right. Creating a constructor for config. So far, we've extracted the logic responsible for parsing the command line arguments from main and placed it in the parse config function. Doing so helped us to see that the query and file name values were related and that the relationship should be conveyed in our code. We then added a config struct to name the related purpose of query and file name to be able to return the values names as struct fields from the parse config function. Just makes it more easy to use, right? And easy to read. So now the purpose of the parse config function is to create a config instance. We can change parse config from a plain function to a function named new that is associated with the config struct. Making this change will make the code more idiomatic. We can create instances of types in the standard library, such as string, by calling string new. Similarly, by changing parse config into a new function associated with the config struct, right, we're using the implementation block, we'll be able to create instances of config by calling config new. So pretty cool. So we're going to make that change now. All right. Let's see. So there's our implementation block. So let's go ahead and move this to an implementation block. I'm just going to say, and again, this is going to be, we're implementing the new function on the config struct. function new, and it's going to be the same function here. I'm going to copy this. Get rid of that. Get rid of that. All right, so here, what do we have? Let's go over it. First, let's move that over. And move that there. All right, so now what we've done is we've taken our new function, which still takes the same arguments, returns the same thing, and we moved it under the implementation block of config. What that's going to allow us to do here is now we can do config new, right? And let's just go ahead and, like they said, we're going to test our program to make sure that it still runs. There we go. We got that pretty boring poem, in my opinion. Not a great poem. And we got the arguments, the and poem.txt. So we're on track. Let's go. We're doing it. All right. Moving on. Pretty cool. So it makes it a little bit nicer, right? It's just like string new, but now we have config new. Pretty cool. All right. We've updated the main function when calling parse config to instead call config new. We changed the name of the block parse config to the new and moved it into the implementation block, which associates the new function with the config struct that we created. We already tried compiling. Everything works. All right, now we're on to fixing the error handling, right? We talked about how we want to make it better. So let's go through that. Now we'll work on fixing our error handling. Recall that attempting to access the values in the arg vector at index 1 and index 2 will cause the program to panic if the vector contains fewer than 3 items. Try running the program without any arguments, and it will look like this. Index out of bounds. All right, so let's try that. Remove our arguments. Let me move out of your way here. Cargo run. There we go. Index out of bounds. The len is 1, but the index is 1. So we don't have arguments, right? So it can't access those. And where is it trying to do that? Well, it's trying to do that right here, right? And it just can't do it. All right, let's see. Improving the error message. In listing 12.8, we add a check in the new function that will verify that the slice is long enough before accessing index 1 and index 2. If the slice isn't long enough, the program panics and displays a better error message than index out of bounds, right? All right, so let's do that. So let's go into our new function. Let me scroll down a little bit for you. All right, so let's just do a quick check in the beginning. If args.len, and we're going to call the len function, is less than 3, we can print a nice message. We're going to use panic for that. Panic, not enough arguments. And I like to do full sentences, just my preference. All right, let's try running it now. Main panicked at not enough arguments. Awesome, we're in good shape. Pretty cool. All right, the code is similar to the guess new function we wrote in listing 9.10. You remember that back in the day, right? We wrote our guessing game, where we called panic when the value arguments was out of range of the valid values. Instead of checking for a range of values here, we're checking the length of the args is at least 3, and the rest of the function can operate under the assumption that this condition has been met. If args has fewer than 3 items, we'll throw that panic. Awesome. With these extra lines, run the program. We did it. We saw that the output's better. We now have a reasonable error message, right? So we have a much better error message. Perhaps using the technique we used in List 910 isn't the best to use here. A call to panic is more appropriate for a programming problem than a usage problem, as discussed in Chapter 9. Instead, we can use the other technique you learned about in Chapter 9 that indicates either success or an error. All right. So here we'll be using a result type instead of just throwing a panic. I like that. We can instead return a result value that will contain a config instance in the successful case and will describe the problem in the error case. When config new is communicating to main, we can use the result type to signal that there is a problem, right? So we can have this thing return a result. That's pretty great. That way, we can change main. So we're going to change main to convert an error variant into more practical error for our users without the surrounding text about thread main and Rust backtrace, that call to panic, all that nonsense that gets printed out, right? We can just make it a nice, easy, human readable message. So the listing below shows the changes that we need to make the return value of config new and the body of the function to return a result. Note that this won't compile until we update our main function as well, which we'll do in the next listing. So let's try coding this out, and then we'll see if we can update main ourselves. So instead of returning config, we're going to turn a result type that's generic over config, and the error is going to be of type static string. I'm not sure what this part means. We'll go into it though, sure. All right, and so here, if it's all good, we're going to return okay, right, wrapped around the config. And here, instead of panicking, we're going to return the error. Now remember, we're in an if statement, so implicit return is not going to work here, so we're going to need to use an explicit return. All right, now how do we consume that? Well, if you remember, we could try using our question mark here, which will, the question mark array can only be used in a function that returns a result or option. So in our case, our main function doesn't do that. So we would need to specify the return type of our main, which would be results, or I think it's, let's try this. Of course, we're going to do it in a second, but let's just try it. What does it say? Ah, okay, so we can't do that. Let's see what happens. I know there is a way to change it, but let's see. So our new function now returns a result with config instance in the case of a success and a reference to a static string in the error case. Recall from the static lifetime section of chapter 10 that static string is the type of string literals, which is our error message type for now. All right, we'll do it. We made two changes to the body of the new function. Instead of calling panic, we return an error value, and we wrap the config in OK. These changes make the function conform to its new type signature. Returning an error value from config new allows the main function, so this here, so returning an error, let me see. Yeah, returning an error from the config new allows the main function to handle the result value returned from the new function and exit the process more cleanly in the error case. All right, so now let's see what we need to change in main. Calling config new and handling errors. To handle the error case and print a user-friendly message, we need to update main to handle the result being returned from config new. Again, it's not just returning the config, it's returning a result, which can either have an OK or an error, right? We'll also take the responsibility of exiting the command line tool with a non-zero error code from panic and implement it by hand. A non-zero exit status is a convention to signal that the process called our program. Non-zero exit status is a convention to signal to the program that called our program, so the program that called our program, that the program exited with an error state. Okay, so we're going to import standard process. You can see that there. So use standard process. And then here in our main config new args, we're going to do .unwrap or else. So unwrap, and if it fails, and here we're giving it a lambda, right? Just like an inline function. What's our inline function to do? It's going to print ln problem parsing arguments, and we're going to print out the arguments. We're going to print out the error here. And then we're going to process. So that's why we imported process exit 1. Very similar. If you've used Node before, you've seen something very similar, right? Process exit. It closes the program. It's telling me the 1 is weird. Let's see what it's saying here. All right, let's see what's going on. So in this listing, we used a method we haven't covered before, unwrap or else, which is defined on result TF by the standard library. Using unwrap or else allows us to define some custom non-panic error handling. That's pretty cool. And the result is an OK value. This method's behavior is similar to unwrap, which we have seen before. It returns the inner value OK is wrapping, right? So it returns that inner value, which in our case would be a config. However, if the value is an error value, this method calls the code in a closure, which is an anonymous function we define and pass as an argument to unwrap or else. We've seen this. We saw this in Rustlings. We've seen it before, I think, in the book. We've definitely used these. Closures, they're inline functions. We call them lambdas in Python. We don't really have a name for them in JavaScript because they're just functions. Most other languages, we would just call them functions, right? Here, we're calling it a closure. So it passes it inside a closure, which is why we have the vertical pipes. The code in this closure can then use the error value when it runs. So that gives us the ability to use it here. Make sense? Pretty cool. We've added a new use line to bring in process from the standard library into our scope. The code in the closure that will be run in the case, in the error case, is only 2 lines. We print the error value, and then we indicate that we want to exit the program by making a call to process exit. The process exit function will stop the program immediately and return the number that was passed as the exit status code. This is similar to panic. Panic-based handling we used in 12.8, but we no longer get the extra output surrounding it, right? Like program panicked at blah, blah, blah. Let's try it. Let's try running it. So let me get out of your way as usual. And I'm going to do cargo run with no arguments. And there we go. No program panicked at nonsense. Here we just get problem parsing arguments, not enough arguments. So pretty cool. Where did that error, not enough arguments, come from? Well, that came right from here, right? So pretty cool. That's pretty awesome. And then let's try making sure that it works in the happy path, right? So if we do cargo run, poem.txt, good. We still get our program working. We have our we have our file name, and we have our poem. Poem, right? It's not that good. It's not a great poem. I said it. It's not a great poem. Sorry, Emily. Not feeling it. All right. Pretty cool. Much friendlier output to our users. Absolutely, absolutely. All right, now we're going to actually talk about extracting the logic from main. All right, so we're going to pull that logic out of main and probably move it into our lib file, right? All right. Now we finish refactoring the configuration parsing, let's turn to the program's logic. As we stated in the separation of concerns section, we'll extract a function named run that will hold all the logic currently in the main function that isn't involved with setting up configuration or handling errors. When we're done, the main will be concise and easy to verify by inspection. And we'll be able to write tests for our logic. Again, we can't write tests for our main function, but we can write tests for other functions. That's why we're going to move everything else out into this run function. So the next listing shows the extracted run function. For now, we're just making the small incremental improvement of extracting the function. We're still defining the function in main. We'll move it to a different file later. All right, so let's do that. So function run takes config, and it's going to do all the stuff we want to do here, which is this part. And here we're just going to call run with config. All right, let's go ahead and test that everything still works. Good, everything's still good. All right, and we've extracted it to a run function. Okay, the run function now contains all the remaining logic from main, starting from reading the file and then printing it, right? The run function takes as an argument the config instance that we created, returning errors from the run function. With the remaining logic separated into the run function, we can improve the error handling as we did before in our config new. Instead of allowing the program to panic by calling expect, the run function will return a result TE. When something goes wrong, we'll have an error. When something goes right, we'll have the OK. This will let us further consolidate into main the logic around handling errors in a user-friendly way. So it makes us consolidate that error handling logic in main and pass back the errors to main so that main can handle it, right? We can see that change in listing 12.12, where we change the body of our config run function to return a result. So let's do that. And you can see here the box. We did a little bit of this, right, in our Rustlings. But let's just go ahead and change that. So config is going to return a result, and it's going to be a result generic over the unit type because it doesn't have a return. In the OK instance, it's just the unit type. It just executes. And the error type, it's going to return a box. And this is just a generic error. So this is just going to represent a generic error. And we're going to actually have to pull that in. Use standard error. All right. And so here it says result, unit type, box, error, error. Now we need to actually return a result. So after this, we're just going to return a result. We're going to just basically wrap the unit type in OK, and we should be good to go. Awesome. So we made 3 significant changes here. First, we changed the result type of the run function to result generic over the unit type and generic over the error of type box dynamic error. This function previously returned the unit type, which is just the unit type. And we kept that as the value returned in the OK case. So we're not changing the return value. It's still going to return the unit type, which means it does nothing. It doesn't really return anything, right? The unit type. For the error type, we use the trait object box dynamic error, and we brought system error into scope with a use statement at the top. We'll cover trait objects in chapter 17. For now, just know that the box dynamic error means that the function will return a type that implements the error trait. Okay. But we don't have to specify what particular type the return value will be. This gives us flexibility to return error values that may be of different types in different error cases. The din keyword is short for dynamic, which is what I've been using. So pretty cool. So it's like a generic error, right? Second, we removed the call to expect in favor of the question mark operator. We didn't do that yet. I didn't do that. Uh-oh. Where did we do that? Ah, here. So here, we got to change that to this and get rid of the expect. That's going to go ahead and throw our error back to the main function. We can also do this. There we go. And I'm just going to run it again, make sure everything still runs, and it does. We're good. All right, so where did it say that? So error, okay, yeah. So second, we remove the call to expect in favor of the question mark operator. As we talked about in chapter 9, rather than panic on an error, question mark will return the error value from the current function for the caller to handle. Okay, so it's going to return the error for the caller, which in this case is main. So main's going to have to handle that, right? Third, the run function now returns an OK value in the success case. We declared the run function success type is unit type, which means we just wrap that in OK. It might look silly, but that's what it does. It's the idiomatic way to indicate that we're calling run for its side effects only. It doesn't return a value that we need. When you run this code, it will compile with a warning saying that we're not using run config. And so if I run that, let's run that code. You'll see that warning. Let me get out of the way here. So here's our warning. Unused, result, that must be used, run config. This result may be an error variant, which should be handled. We didn't handle it yet, right? So it's telling us we need to handle this error. That's pretty awesome. This is why we like this stuff, right? It gives us tips. It's like, you need to handle that error. You're just going to let that error, you're just going to let that error. You're not going to handle that? Yeah? I don't know. JavaScript be like, that's fine. Russ is like, oh, you're not going to handle that? All right, no, I'd handle it. I'd handle it if I were you, right? Russ tells us our code ignored the result value, and the result value might indicate an error, but we're not checking to see whether or not there was an error. And the compiler reminds us that we probably want to do that, right? We probably want to handle that error. That's what we're here for. Come on. Handling errors returned from run in main. So we're going to handle that error up here, right? We'll check for errors and handle them using a technique similar to one we used with config new in listing 12, but with a slight difference. All right, let's check out this slight difference. So we got our print searching for blank, run config, but we're actually, here we have an if statement. So let's go ahead and write this if statement out. If let error e equal run config. So we saw if lets in rustlings, and they're going to go into a little bit here. We've seen these in rustlings though. So we know if let, it's going to set the variable if the condition is true. So if let run config, print ln application error, and then we'll print that error out as E, and then we'll exit the process. Process exit 1. Okay, so let's see what this is doing, because we did a little bit here, right? If let, what does it do? We use if let rather than unwrap or else to check whether run returns an error value and call process exit if it does. The run function doesn't return a value that we want to unwrap in the same way that config new returns a config instance. Because run returns the unit type in the success case, we only care about detecting an error, so we don't need unwrap or else. To return the unwrap value. We don't care about the value, so there's no use in unwrapping it. So we just explicitly check for the error. Makes sense, right? Like we don't need, here we needed config, so we wanted to use unwrap. We're not unwrapping anything. It's like when you're bad and you get nothing for Christmas. You can't unwrap it, right? There's nothing, fake out. There's nothing in any of them, right? So nothing to unwrap. We don't need it. We'll just check for the error and be done with it. So pretty cool. Now we have an error here, and it says it's being used after move. So we'll see that in a second, right? We don't need this anymore because it's actually being called here. So we just get rid of that. So now I'm just going to run the code and let's see if everything still works. Let me just move out of the way as usual. And let's run it. And bam, no warning, code works. We got the poem. You all know how I feel about the poem. We got it. Let's move on. All right. Here we go. Splitting code into a library crate. We're gonna get real with it. Strap in. We're learning Rust. Splitting code into a library crate. Our mini grep project is looking good so far. Now we'll split the main RS file and put some code in the libRS file so we can test it and have a source main file with fewer responsibilities, right? Single responsibilities, microservices, micro functions, right? Come on. Breaking up the code. Let's go. Let's move all the code that isn't in the main function from source main to source libRS. All right, so what are we going to move? We're going to move the run function, the relevant use statements, the definition of config, the config new function definition. We're going to move that all to libRS. So we go ahead and create that. So here we'll go over here. Oops, sorry. Let's open up here. We'll do lib.rs. What I'm going to do for now is I'm just going to copy the contents and we'll just get rid of what we don't need. Let's do this. Wait, what happened here? Oh, wrong file. Oh, I put it in guessing game. My bad. We need it here. Let's get rid of that. 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 Okay, so here's mini grep. So here we need a lib.rs. Okay, so we want to take all of this and put it here. And what we'll do is we'll get rid of the main function. We no longer need process because we're not using process, but we still need file system and an error because we are still using those. And you can see here we have config, run. So we're all good. In fact, they put config up top, so we will do the same. Awesome. Note that this won't compile until we modify main. So we're going to have to modify main to use this, right? Oh, the other thing, env. Env is actually being used in main, so we don't need env here. Cool. So we just need error and file system. Pretty straightforward. Pretty cool. Easy. Okay. We've made liberal use of the pub keyword. I didn't see that. Where do we do that? Oh, okay. So let's make sure we have to make these public because we're using it from another file. So struct, we need to do pub. We want to make them public. We're going to make the new function public, and we're going to make the run function public. All right, now let's read this. We've made liberal use of the public keyword on config, on its fields, in the new method, and in the run function. We've used it everywhere, right? We now have a library crate that has a public API that we can test. Now we need to bring the code we moved to source lib into the scope of the binary crate in main so that we can use it, right? So let's pop over to main here. and we're going to pull it in. So how are we going to do it? We're going to say use mini grep, right? Config. Pretty cool. And why are we able to use mini grep config? Because it's here, right? Pub struct config. And it's in librs, so we can just say mini grep, right? We don't need to specify lib.rs. It's going to, by default, pull that in. So now we have use mini grep config. We'll put a semicolon there. What is it saying? Use of undeclared file type mini grep. Why? Let me make sure this is spelled correctly. Lib source mini grep. Mini grep. Yeah, it should be right. Let's see. All right. Let's see if it complains, and we can try to figure that out. So what we're going to do here is use mini grep, and then in the if-let, instead of calling run config, we're going to call mini grep run config. And so it's complaining. Let's see if we can figure that out. So it says here, we add a use mini grep config line to bring the config type from the library crate into the binary crate scope, and we prefix the run function with our crate name. Now all functionality should be connected and should work. Run the program called run and make sure everything works correctly. So it doesn't. So let's see why not. And I'm assuming it might have to do with how we create our library crate. So we have the contents of source librs should have the signature shown. All right, so let's make sure we have the correct signature. So in our lib, we have pub struct config. That's right. Pub function new, pub function run. We've called the file librs. That's correct. The file lives in source. That's right. And it's in a folder called minigrep. So why is it not able to pull it in? Let's see. Let's make sure nothing's wrong with librs. All right, I don't see anything wrong here. So why can't we pull it in here? Let's see if there's any autocomplete that'll help us out. Let's see. Use of undeclared typer module minigrep. Unresolved import minigrep. Why won't it let us use it? Let's see if there's a fix. No quick fixes. Unresolved import minigrep. All right, so why can't I use minigrep? It's there. It's in librs, inside source, name minigrep. So that's right. Let me try something. Let me try doing cargo build real quick and see if that helps in any way. Well, let's see what happens. Config. Oh, because we have to remove the stuff from main, I think, because we have some, it's not able to build. So we get rid of that stuff from main. Now we can get rid of these imports. Now let's see if we can build it. All right, so it built it, but it's still saying minigrep is unresolved import. Let's do a search. Let's see if it's come up before for others going through this. Let's see. I'm using VS Code for editing building and executing from the command line using cargo. I could not get the error to go away in the editor, but I was able to build and run it with no problem. Exited and restarted it. Okay, so maybe what we can do is just close main, reopen main. Let's try running it. So it says that we're able to run it. So let's try and see if we can run it, and then we can figure out what's going on with that error. So I'm going to clear this out. I'm going to run cargo run. Awesome. So it still works. So this error is probably just kind of like a thing with the editor. So what if we did reload workspace Rust analyzer? Nah, that didn't work. Reload. Let's reload the window. Awesome. So that did it. We got a new download Rust analyzer server. Got it. All right, so that actually worked. No complaints. Little weird that happened, but hey, quick Google search solved it, right? Thank you, Google, and thank you for ever ran into that problem. So there we go. So we abstracted our code into a librs file. So we have our main function, which is just responsible for handling errors and delegates out to mini-grep run, and mini-grep run is the code here. Now we can write tests for that code. All right, moving on. So that was a lot of work, but we set ourselves up for success in the future. Now it's much easier to handle errors, and we've made the code more modular. Almost all of our work will be done in source lib from here on out. Let's take advantage of this newfound modularity by doing something that would have been difficult with the old, but is easy with the new code. Let's write some tests. Yo, I'm ready to write some tests. Hope you're ready to write some tests. Let's dive right in. Let's go. Let's see how much is left of this chapter. All right, so I think we'll get through this part, and then maybe we'll stop after this. We're pretty good on time. Developing the library's functionality with test-driven development. Now, if you've ever done test-driven development, if you haven't done it, quickly what it is, it's writing tests, right? You write your tests, you get your code to pass, then you refactor your code, leaning on those tests to tell you if you break anything during the refactor process. We did a little bit of it during Rustlings. It's a lot of fun when possible. It's not always something that's easy to do. Let's dive in and see what we're going to do here with our command line program. All right. Now that we've extracted the logic into source lib and left the argument collecting and error handling in main RS, it's much easier to write tests for the core functionality of our code. We can call functions directly with various arguments and check return values without having to call our binary from the command line. Feel free to write some tests for the functionality in config new and run functions on your own. All right, so we can write some tests on our own for those. In this section, we'll be adding the search logic to mini-grep program by using the test-driven development process. So we're gonna write tests first and then write the code. So we'll skip over writing the test for config new and run. We'll go back and add those. Let's see if we can just get through this part first. This way we don't have to cut this chapter short. So we're gonna add the search logic. We're gonna do test-driven development. We're gonna write the test first. So write a test that fails and run it to make sure it fails for the reason you expect. Then we're gonna write or modify just enough code to make the test pass. Then we'll refactor the code that we just added and make changes and make sure the tests continue to pass and repeat from step one. Why do we do this? Again, it's because you wanna write the test, get it to pass, write your code however you need to get it to pass, then refactor that code. If at any time your refactoring causes issues, your test will let you know. So you have that test to lean on, right? So pretty powerful stuff. This process is just one of the many ways to write software, but test-driven development can help drive code design as well. Writing the test before you write your code that makes the test pass helps to maintain a high test coverage throughout the process. It also makes sure that you write nice refactored code too. We'll test drive the implementation of the functionality that will actually do the searching for the query string and the file contents and produce a list of lines that match the query. We'll add this functionality in a function called search. So first we're gonna write that test that fails, right? Look, Rustation made it. Woo! Writing a failing test. Because we don't need them anymore, let's remove the print line statements from our librs and main.rs that we use to check the program's behavior. Then in librs, we'll add a test module with a test function, as we did in chapter 11. The test function specifies the behavior we want the search function to have. It will take a query and the text to search for the query in, and it will return only the lines from the text that contain the query. So we have the test below. So first let's remove those print lines. There's one there. And here's one in our main. Let's see. So we got the one here. Problem parsing arguments. Get rid of that. Get rid of these. get rid of that. So much nicer. And we'll handle, we'll have our test. So our test is going to go into our librs, and we're going to add it down here. We're going to add a module, mod tests. And we need to add that trait here, config test. And we're going to say use super. It's our test setup. And then here we're going to have our test. So test, let me get out of the way here. All right, so we have our test. Cool. All right, so we're going to test one result. So one result, let query equal duct, let contents equal, and we're going to create our content right now in line. And so our text is Rust, safe, fast, productive, pick 3. Because it's all, huh? All right. So our query is duct, contents is this here. Let's move this up here, let's get rid of that. And so we're gonna assert equal. Remember we learned about assert equal, right? So we're gonna assert equal, we're using that macro, vector, safe, fast, productive, comma, search, query, contents. Okay. So what are we doing here? One result. So we have our query is duct, our contents is slash, that's just, you know, to indicate the line here, Rust, safe, fast, productive, pick 3. And then we're asserting that it returns the line safe, fast, productive when we search with the query and the contents. This text searches for the string duct. The text we're searching is three lines, only one of which contains duct. I don't see duct anywhere in these lines. What? Weird. Oh, duct is in productive. I see. Not whole word, just the piece of the string. Duh. Come on, Tom. Come on. All right, so the test searches for the string duct. The text we're searching is 3 lines, only one of which contains duct. We assert the value returned from the search function contains only the line we expect, right? And so that's here. We expect it to contain this. Now search doesn't exist yet, hence the issue here. We aren't able to run this test and watch it fail because the test doesn't even compile. The search function doesn't exist. So we'll need to add just enough code to get the test to compile and run by adding a definition of the search function that always returns an empty vector. That'll make the test fail. The test should then compile and fail because it doesn't match safe, fast, productive, which is what we expect. So let's go ahead and write that function. Search query is of type string slice, and the contents of type, and we didn't learn what these are yet. We're about to learn it. And it returns a vector of, and yeah, we're about to learn what this A thing is here. And we'll return vec. All right. Let's run it. Hold on. Let's keep going. We'll run it in a second. All right. Notice that we need an explicit lifetime. This thing. Oops, sorry about that. Oh, I'm back. Sorry, good call. How long did that cut out for? Hopefully not too long. Audio is back. Was it out for a while? Uh-oh. Cool. Clam Watson in the chat said no audio. How long was the audio out? Hopefully not a while. Okay, maybe. Okay, so it was out when I did this. Probably. Okay, cool. Whew. All right, so let's go back. Sorry about that cutout. Basically, all it's saying is we're using this lifetime A. It's defining that we're going to generate a string slice from contents instead of from query. Make sense? All right, sorry about that audio drop. Thanks for the heads up, Clam. Appreciate it. All right, so let's see. Rust can't possibly know which of the two arguments we need, so we need to tell it. Because contents is the argument that contains all of the text and we want to return the parts of the text that match, we know contents is the argument that should be connected to the return value of the lifetime syntax. Make sense? Other programming languages don't require you to connect arguments to return values in the signature. Although this might seem strange, it will get easier over time. You might want to compare this example with the validating references in lifetime section in chapter 10. All right, so now let's run the test. We'll get out of your way. Bottom left. Cargo test. We got some warnings. That's okay. It's just some unused things, right? And our test failed. So here we can see running one test, one result failed. One result panicked at assertion failed. Left does not equal right. The left is safe, fast, productive, and the right is nothing. So we have our failing test. Now we can write our code to make that test pass. All right, so let's go in a little bit. Writing code to pass the test. Currently, our test is failing because we always return an empty vector. To fix that and implement search, our program needs to follow these steps. 1. Iterate through each line of the contents. 2. Check whether the line contains our query string. 3. If we see it contains the query string, we need to add it to the list of values we're returning. If it doesn't, we skip it. And then it needs to return the list of results that match. Let's work through each step, starting with iterating through lines. And again, we're just going to write the code, get the test to pass, and then we can go back and refactor. That's the beauty of it, right? Iterating through lines with the lines method. Rust is a helpful method that handles line-by-line iteration of strings, conveniently named lines. That works as shown in listing 1217. Note this won't compile yet. Okay, so let's kind of code that up. It's not going to compile yet, but that's okay. For line in contents.lines, and we're going to do something. All right, the lines method returns an iterator. We'll talk about iterators in depth in chapter 13. We have talked about them in the rustlings exercises, so we've worked with them a little bit, right? So this is going to return an iterator. But recall that you saw this way of using iterators before, right? Where we used a for loop with an iterator to run some code on each item collection. So we did it in chapter 3. All right, searching each line of the query. Next, we'll check whether the current line contains our query string. Fortunately, strings have a helpful method named contains. That does this for us, right? That contains will just do the check. Add a call to contains method in the search function as shown in listing 1218. Note this still won't compile yet. Okay, all right, let's try it. So we're going to do an if statement here. If line.contains query, then we're going to add it to our return, right? Okay, storing matched lines. We also need a way to store lines that contain our query string. For that, we can make a mutable vector before the for loop and then call push method to store a line in the vector. After the for loop, we'll return the vector. Okay, so let's create it out here. We're going to create a mutable vector. So do let mut results equal vec new for line contents if line contains, right? And so what we'll do is we will do a results.push line. All right, let's see. Contents is a string, lines. What is this complaining about? For line contents. We have to return it because it's the explicit return, right? Okay. Now the search function should return only the lines that contain query, and our test should pass. Let's run the test. Whoa, sweet. Let's see if it passes. Let's pop this thing open, clear it out, cargo test. Test failed. Here's what we got. Safe, fast, productive, and on the right side we have a bunch of empty space. So that's because of the formatting of our string. So we can get rid of that by just simply doing this. Clear that, cargo test. Awesome, our test passed. So you can see here, running one test, test one result, okay. One pass, 0 failed, 0 ignored, 0 measured, and 0 filtered out. So awesome, so our test passed. Now we can go and refactor that code so we have a less nesting and make it a bit nicer, which is what they're gonna have us do now, I'm sure. All right. At this point, we can consider opportunities for refactoring the implementation of the search function while keeping the test passing to maintain the same functionality. The code in the search function isn't too bad, but it doesn't take advantage of some useful features of iterators. We'll return to this example in chapter 13, where we'll explore iterators in detail and look at how to improve it. Okay, so we're not going to improve it right now. Kind of wish we did, but we're not going to. That's fine. Well, who am I? Who am I to say the wisdom of the book authors? So we'll return to it. All right, using the search function in the run function. Now that the search function is working and tested, we need to call search from our run function. We'll need to pass the config query value and the contents that run reads from the file to the search function. Then run will print each line returned by search. So we have our search function, we have our run function. Let's modify our run function. So what we're going to do is we have our contents read to string. What we're going to do here is we're going to say for line in search. We'll get a reference to config query, right? That's what our thing takes. And we will pass it a reference to contents. And so this is going to be for each line in, because again, this is returning a vector. So we're going to loop over that and print each one. Print ln, and we're just going to print it with the standard debug, right? Or standard display, I think that is. Yes, so let's do that. Now the entire program should work. Let's try it out. First with the word that returned exactly one line from the Emily Dickinson poem, Frog. All right, let's try it out. I'm excited. Did we get it to work? All right, so let's go. Let's try cargo run, and let's do frog. How public like a frog. Very cool. Let's try it with the. Let's actually clean up these. Let's clean up these warnings because I think it'll make the output cleaner. So first, our warning is on line 11 of main. It's saying we have an unused error, which I believe is correct here. So we are unusing this, so we'll just mark it like that. Same thing here. We're actually not using this, so we'll just mark it like that. Actually, I think we did want to print these ones. Yeah, we do want to print those. Let's leave those. And so now we should be good. So let's go ahead and clear this out. There we go. How public like a frog. And now let's try searching for the word the, which should appear a few times. Then there's a pair of us, don't tell, to tell your name the live long day. Very cool. This is pretty awesome. Finally, let's make sure that we don't get any lines when we search for a word that isn't anywhere in the poem, such as monomorphization. All right, yeah. We're gonna search for Twitch because Emily Dickinson, she wasn't with it. I don't know if you all know, she wasn't as like with it as we are. She didn't know about Twitch back in the day. I'm sure she'd be a great streamer if she did. Let's go ahead and search it. Nothing comes up. Awesome. Fantastic. All right, pretty cool. We got our test working. We got my audio working. Thanks, Climb Watson, again. Appreciate it. And that's pretty awesome. What's next? Working with environment variables. All right, let's see how far we can get through this. We still have about 15 minutes. Let's see. We'll improve mini grep by adding an extra feature, an option for case insensitive searching that the user can turn on via an environment variable. We can make this feature a command line option and require that users enter it each time they want to apply. But instead we'll use an environment variable. Doing so allows our users to set the environment variable once and have all their searches be case insensitive in that terminal session. Writing a failing test for the case insensitive search function. So we want to add a new search case insensitive function that will call when the environment variable is on. We'll continue to follow the test-driven development process, so the first step is again to write a failing test. We'll add a new test for the new search case insensitive function and rename our old test from oneResult to case sensitive to clarify the differences between the two tests. All right, so let's do that. So here we have our first mod, and we'll call this case insensitive. So change it from oneResult to case in, we'll call it case sensitive. And that should be good. And then we're gonna add a new test. Case insensitive. All right, and let contents equal. And we're gonna do the, okay, so let's copy their strings that they have here too. Perfect. All right. There we go. And what we're going to do here is we're going to assert equal we're going to assert that we get a vector with the following: rust colon, right? We should have two things: rust and trust me. Oh, that's cool. I like that. Clever. And we want to assert that that's in search, which this function again doesn't exist yet. Search case insensitive query contents. Let's make sure I spelled that right. Insensitive. Okay. Now we need to implement that function. Note that we've edited the old test content too. We added duct tape using a capital D, which shouldn't match duct, so we want to make sure that test still is correct, right? When we're searching in a case-sensitive manner, duct lowercase d will not match capital D duct. Changing the old test case in this way helps us ensure we don't accidentally break the case-sensitive search functionality that we've already implemented. This test should pass now and should continue to pass as we work through case-insensitive search. Let's try that. So first I'm going to just create that search case-insensitive so we can get this to compile. And what I'm just going to do here is I'm just going to call search with query with contents. So that should compile. And now if I run cargo test, the second one should fail, but the first one should pass. Yeah, so one passes, one fails. So that's exactly what we want. Awesome. All right. All right, implementing the case insensitive search function. So it'll be almost the same as the search function. The only difference is that we'll lowercase the query and each line so that whatever the case of the input arguments will be the same case. So we're going to go ahead and just copy the contents here. And instead, what we're going to do is we're going to lowercase these things. So what we'll do is we'll say let query. Oh, sorry. Let query equal query.to lowercase. And then for here, we're going to do line contains, and we're going to do line.to lowercase dot contains query. And here we shadowed query. So this is shadowing, remember we can change it. And here it's complaining because it expected a string function car closure found string. And that's because we need to do this reference, right? Because that's what lowercase returns. Cool. All right, first we lowercase the query string, store it in a shadow variable with the same name, right? And then we call to lowercase on the overall comparison. Note that the query is now a string rather than a string slice because calling to lowercase creates a new data type rather than referencing the existing data. Say the query is Rust. As an example, the string slice doesn't contain a lowercase u or t for us to use, so we have to allocate a new string containing Rust when we pass the query as an argument to the contains method. All right, let's try it out. Oop, let me just move over here out of your way again. Save it. Oh, what's happening here? Hold on one second. I think my auto hotkey got messed up. Let me just double check that. There's my cool background. All right, back to here. And let me open this back up. All right, there we go. So let's save that. And I'm going to clear this. Give me 1 second. Let's exit that. Turn off caps lock here. And we will turn this back on. Yeah, so I'm using auto hotkey, which is great because it lets me hotkey some of my Vim commands. All right, so let's clear that and run cargo test. And there we go. Both tests are passing. Awesome. So we have our search functionality works. It's pretty great. Next, what it's going to have us do is actually pull in from an environment variable. We're pretty close to 11 though, so I think we're going to stop there with the 2 passing tests. And next week, we'll pick it up pulling from the environment variable so that you can actually set your preference ahead of time. Awesome. So yeah, pretty cool stuff so far. We got started with the command line program. I'm sorry again for the audio drop for the few minutes there. I'll make sure when this gets uploaded to YouTube, hopefully I'll cover that with some, I'll just dub over that. If you missed it on stream, hopefully I went back and covered what was missed. But yeah, so that's it for this week. We got our 2 tests to pass. We got our search case insensitive and our search function working. Next week, we'll pick it up pulling from the environment variable. And yeah, thank you for watching the stream. If you're catching on Twitch, if you're catching on YouTube, I appreciate it. Obviously, subscribing and liking always helps me. It also helps you get notified when new videos are posted. As usual, I post my videos the following day up on my YouTube channel, so you'll see them here. They'll be posted on YouTube. So probably around tomorrow afternoon, they'll have the full high-def version of the video. Follow on Twitter for any updates on when I go live. I post there, so if you want to get notifications, you can also follow on Twitch if you want to be notified when I go live. And again, I'll be posting the code to the Learn Rust Live GitHub repo. So thanks again for hanging out with me tonight. Or, if you're watching on YouTube, thank you so much. I've been really loving the comments. Keep them coming. Keep the questions coming. We're going to keep going with this. Next week, we will be picking up, again, Tuesday, 9 p.m. to 11 p.m. on Twitch. We'll be picking up from Chapter 12 again. We're going to be implementing the environment variables to actually set your preference on how you want the grep functionality to work. Thanks for hanging out. It's been a really fun night. Awesome time. I've been really enjoying writing this program. It's pretty cool. We're learning about test-driven development, implementing, a cool program. We're using the Rust skills that we've learned in the book so far. As usual, Twitter below, YouTube below. Thank you so much for hanging out. Everybody have a great night.